So in this video, we're going to talk about energy and chemical bonds. All right, so first we're going to talk about this essentially two types of energy, right? So we have potential energy and then we have kinetic energy. Now, potential energy is energy, a stored energy, or energy that's stored within a system or within a particle per se. So for example, if you're thinking about potential energy, you can think about when you take a spring and you coil it up, right? And right before it moves, okay, so there's energy stored within that spring. If you think about like water in the reservoir behind a dam, that's energy stored up. Versus you have kinetic energy, which is energy of motion. And so it's usually as things are moving, this is kinetic energy, and the energy that is within that substance itself. So, when water falls from a dam and it turns to turbine, that's kinetic energy. That's potential energy turning to kinetic energy. Or a car rolling down a hill versus it standing still. All right, kinetic energy. When you finally release the spring and as it uncoils to make whatever it needs to make move. Thus, that is kinetic energy. So in terms of chemical compounds, if you think about the attractive forces between ions or atoms, so like for example, if we have a cation and an anion, right, and they are attracted to one another, all right, this attraction is in the form of potential energy. All right, it's energy that is stored. All right, this attraction. And when these attractive forces result in the formation of these bonds, so, due to the attractive forces, and all of a sudden you see that the cation and the anion are bonded together, right? The potential energy is then converted into heat. All right. Now, heat is just a measure of kinetic energy of the particles that make up the molecule. So it's kind of synonymous to kinetic energy. Okay, so once again, you have the attractive forces that these atoms or ions have for one another. So here I just showed you a picture of an ion, but atoms could do the same thing. All right, attractive forces for one another. And then when the attractive forces, or when this potential energy then will form ionic compounds or covalent bonds, or ionic bonds and covalent bonds. So this potential energy would then turn to heat, in other words, kinetic energy. All right. So now in chemical reactions, some of the chemical bonds in the reactants must break so that new bonds can form in the products. So let me kind of give you an example of what I mean by that. So let's just say we're looking at a decomposition reaction of carbon dioxide, right? So we have CO2, it gets decomposed to make carbon and oxygen. All right, so let's look at this from a molecular level and see what's kind of going on. And so let's say we have carbon here. So this is our carbon atom. All right, and I'm gonna make this green. All right, and this carbon atom, it's bonded to, actually, let's kind of draw this correctly ish. Whoa. All right, so it's bonded to these oxygens here. So these are our oxygens. Now, in order for this reaction to take place, we need to break these bonds. All right. In order to break these bonds, you need an input of energy. All right. All right. So you need energy to break these bonds. So energy is placed into this to break these bonds. When these bonds are broken, you see that carbon now sits by itself. And then if you pay attention to this chemical formula, we see these oxygens are now bonded together. And so in this case, when you have the oxygens bonded together, all right, you form a new bond. Now this bond releases energy. Okay, so to make this clear, anytime in a chemical reaction, when you're breaking bonds between two atoms or two ions, whatever the case is, you need an input of energy. Okay, well, other words, we typically call it's an endothermic process. All right, breaking bonds is an endothermic process. You need an input of energy. All right, and anytime in the product side, when you're forming bonds, in this case, we formed a bond between these oxygens. All right, you are releasing energy. All right, and so when it's releasing energy, it's said to be exothermic. All right. So if the reaction products, in this case, we're talking about CO2, C, carbon, and oxygen here, right? So the reaction products have less potential energy than the reactants. So we have less potential energy. Okay, and this side, on the product side, we have more potential energy. Now, then we could say that the products are more stable than the reactants. All right. So the term stability, in this case of chemistry, is that we're describing that the substance have a very little remaining potential energy, and ultimately it may not undergo further chemical changes or further chemical reactions. All right, so whether a reaction occurs, how much energy or heat is associated with the reaction depends on, the difference in the amount of potential energy containing in the reactants and the products. All right, and so in this case, this might be the situation, but then it could be the other way around, right? If the reactant has less potential energy than the products, all right, then we could say that the product is less stable than the reactant. All right, and then the tendency to undergo further chemical reactions can take place.